You know that feeling, right? That huge sigh of relief when your code finally works. But here's the thing. Getting it to run is just step one. Today, we're talking about making that jump from code that's just functional to code that's genuinely efficient. We're going to cover the skills you need to build software that isn't just working, but is truly performant and ready to scale.
So let me ask you this. Does this sound familiar? You've built something. It crushes your small test cases. But the moment you throw some real-world large-scale data at it, it just crawls. It's a super common challenge for developers, and it's exactly what we're going to tackle right now.
And look, this isn't just some nice-to-have skill. The big tech companies are incredibly open about this. This quote from Amazon's own evaluation guide, it's crystal clear. They don't just want an answer, they want the best answer. A brute force approach, just throwing processing power at a problem, might work eventually, but true, elegant efficiency, that's what gets you noticed.
So here's how we're going to break it all down. First up, why good enough code just isn't enough. Then we'll get into why efficiency is so critical. After that, we'll cover the 3 foundational pillars you've got to master. Then we'll get practical with micro and macro practice, and we'll wrap it up by talking about how to think at a massive scale.
All right, let's dive into our first big idea. Functional code is the starting line, not the finish line. We're aiming for excellence. So what's the real difference we're talking about? Well, functional code, it usually works fine with simple inputs, but it can be slow and honestly, kind of brittle. It often completely ignores edge cases, those weird, unexpected inputs that can crash a whole system. Efficient code, on the other hand, is built for the real world. It's scalable, so it performs great even with tons of data. It's fast, and most importantly, it's robust, so it handles those tricky edge cases without breaking a sweat. But why is this so critical? I mean, really, why all the fuss? Because when you're playing in the big leagues, at the level of a tech giant, efficiency stops being a nice feature. It becomes the absolute standard. Think about a company like Amazon. They're not just hiring you to solve a little coding puzzle. They're hiring you to tackle incredibly complex problems inside massive, interconnected systems. And that one word, scale, changes everything.
Just try to wrap your head around this number. Hundreds of billions. That's how many requests some of Amazon's key systems process every single day. At that kind of scale, a tiny little inefficiency, something that seems totally harmless in one line of code, doesn't just cause a small slowdown. It can cascade into a catastrophic system-wide failure. This is why optimization isn't a feature, it's a survival mechanism.
And this right here breaks down exactly what they're looking for in a software development engineer, or SDE. It's about owning the whole process, designing, coding, testing, and maintaining solutions for complex problems at scale. See how every single part of that job description points right back to the need for efficient, reliable code?
Okay, so how do you actually build these skills? It really boils down to mastering 3 fundamental technical pillars. Think of these as the bedrock for every piece of efficient code you'll ever write. Pillar number 1 is data structures. These are the basic ways you organize and store your data. It is absolutely crucial to understand their runtimes, how fast they are, and how much memory they eat up. For example, choosing a hash map for a near-instant lookup instead of slowly iterating through an array, that's not a style choice. That's a critical performance decision that can make or break your application. Second, we have algorithms. And the secret here isn't to just memorize a bunch of them from a textbook. It's about understanding the strategies. When should you use a divide-and-conquer approach to break a huge problem into smaller pieces? What are the trade-offs between different ways of searching through data? That kind of strategic thinking is what lets you solve brand new problems efficiently. And our third pillar? Object-oriented design. This is what keeps your code from becoming a tangled, unmaintainable mess down the road. Knowing common design patterns helps you build software that's not just fast today, but is easy for your whole team to understand, build on, and scale for years to come. Okay, so we've got the theory down, but how do you actually get good at this stuff? It all comes down to practice, and you've got to attack it from 2 different angles. So you need to practice on 2 levels. At the micro level, you're focused on logic and algorithms. This is where you solve those specific, bite-sized problems to really sharpen your core programming brain. But then, you also need to practice at the macro level, where you zoom all the way out to system design and architect entire, large-scale systems from scratch. For that micro practice, think of sites like LeetCode. Those classic problems like toSum or contains duplicate are perfect for mastering your data structures.
Others, like merge two sorted lists or finding the longest substring, are great for honing your logic. This is like your daily workout at the coding gym.
And then, for the macro practice, you tackle the really big questions. How would you actually design Netflix to handle millions of streamers? What are the key pieces you'd need to build Uber? How would you design a rate limiter to protect a system from being overwhelmed? These cases force you to think about databases, caching, load balancers, all the moving parts of a massive system. In all of this practice, the micro and the macro, it's all building towards our final, most important point, developing the right mindset. This is what truly separates a good developer from a high-impact senior engineer.
The heart of this mindset is a major shift in perspective. You stop just solving the problem that's right in front of you today. Instead, you start building systems that need to live, breathe, and evolve for years into the future.
So what kind of questions does a senior engineer ask? They ask about scalability. Sure, this works for 10 users, but what about 10 million? They think about fault tolerance. What happens if this part of the system fails? Do we have a backup? They think about maintainability. Will another developer understand this code 6 months from now? And above all, they are always thinking about the end customer's experience.
This all leads to an incredibly powerful piece of advice, and it comes straight from Amazon's guide. In everything you build, whether it's on an interview whiteboard or for a daily task, your goal should be to write code that's as close to production ready as you can possibly get it.
And why is that so important? Because that one habit shows everything. It shows you know how to apply design patterns. It proves you're thinking about performance from the start, and it demonstrates you can write correct, solid code. It's basically proof that you already have that senior engineer mindset.
So, let's wrap this up with the single most important takeaway. In modern software engineering, especially at scale, efficiency isn't a luxury. It's not some extra feature you bolt on at the end. It is the standard, right from day one. So I'll leave you with this to think about. Based on everything we've talked about, from data structures to system design to that senior mindset, how are you going to approach your next project differently? How will you build optimization in, not as an afterthought, but from the very first line of code? Thanks for tuning in.